One thing that we need to make sure that we understand that distinguishes horizontal asymptotes from verticals is that graphs can cross horizontal asymptotes because they only tell us the end behavior. That's something that you need to make sure that you understand. They only tell us what's happening on the outsides of the graphs. So what's inside in the middle part, it could cross. So here's what we have to do. To determine if it does cross, you set the rational function equal to the horizontal asymptote. Okay, so when we look at this first one, this is one we looked at earlier, this one has a horizontal asymptote at y equals 0. So to figure out if it crosses, all we're saying is, does this function ever achieve a y value of 0? So we put this in, we multiply both sides, right? And multiply both sides by x plus 2 to help us solve here. Okay, then we get 0 equals 1. Does that happen? No. If that doesn't happen, then we can say, in this case, f of x does not cross y equals 0, or its horizontal asymptote. Okay? Let's try it again. Another one, a little more difficult. In this case here, if we look, this one has a horizontal asymptote, right, at y equals 1. That's because the degrees are the same, okay, and so we would look to the leading coefficient over the leading coefficient, which would be 1 over 1, which is 1. Okay, so we need to say, alright, does g of x ever equal 1? Okay, we would multiply both sides by the denominator, and we get x squared plus 4x plus 4 equals x squared minus 1. Subtract an x squared from both sides. Get 4x plus 4 equals negative 1. 4x will then equal negative 5. Okay? So I would subtract a 4 from both sides, and then we'd get x equals negative 5/4. Now what that tells us is, this graph here, what that tells us is g of x then crosses y equals, oops, got our 1 up here, y equals 1, which is our horizontal asymptote, at x equals negative 5/4. Okay, so it does cross it. It will only cross it in that spot.